So let's take a look at what the physiological differences are between serum ferritin and ferritin inside the cell. So there was this one paper in 1981 looking at the characteristics of ferritin in those diagnosed with hemochromatosis, right? So think about that for a second. Take this all kind of in the context of these people have too much iron being stored away in their body. Okay, so this is a little bit of a diseased state observation. But what they found was the serum ferritin of those with hereditary hemochromatosis were glycosylated. What that means is that it has a carbohydrate molecule attached to it, which alters its function to some degree. And the altered function was that ferritin stayed in circulation longer. Okay, typically, every molecule protein enzyme has a cycle of being in circulation, either broken down and disposed of, or taken back into the cell to continue the cycle of in and out, up, down, recycled, reused, recycled, reused. And glycosylation altered that cycle for ferritin. They also found that the storage capacity of serum ferritin was significantly lower than storage protein. You remember before I mentioned that ferritin can hold 4,500 molecules of iron. This found that it was less than 10%. Less than 10% of that 4,500 was what serum ferritin could hold. So that kind of throws a wrench in the mix of those that are like, oh yeah, ferritin's just a transport protein as well. It's like, for the capacity that it has, it's not holding very much. Something has changed its structure and its function so that it can't hold as much iron. And then they still couldn't quite answer the question as to why ferritin is getting outside of the cell. Then there was another study, this is from 2009, looking at ferritin's role in inflammatory cascades, right? So this is kind of along the lines of ferritin may not be a very good thing outside of the cell. It may be causing things that we don't want it to cause. So this is a call for us to really find a way to get ferritin back inside the cell. So ferritin functions as a pro-inflammatory cytokine via iron-dependent PKC, NF-kappa B regulated signaling in rat hepatic stellate cells. A lot going on in that title. We're going to talk about all of it. So what the paper found was that serum ferritin levels are elevated with inflammation in chronic liver injury, right? So again, we're looking at a diseased state here, but it's saying that in those experiencing the inflammation associated with liver injury, serum ferritin levels are always elevated. Now, stellate cells, which is a specific type of cell in the liver, are responsible for driving fibrogenesis in response to tissue injury. So fibrogenesis is basically making scar tissue, right? This is a protective measure, right? If our cells keep taking a beating, whether from bacteria, a virus, our own immune system, this is a way to kind of like calcify and kind of like kill off the tissue to prevent any more reaction. So researchers looked at these stellate cells because people with chronic liver injury are experiencing a good amount of this scar tissue generation. Think of, an alcoholic with cirrhosis or someone with, what's that disease where they turn jaundice? It's not just, their liver doesn't work as well. It's like the tissues are calcifying and the actual structure of the liver is dying. So researchers looked at these stellate cells and found that they had a special receptor for ferritin, and that those increased levels of ferritin were influencing the activation of the stellate cells. So I mentioned before, stellate cells are specifically found in the liver, responsible for the formation of scar tissue, and they are the root of fibrotic tissue in the liver in response to liver damage, okay? Which is something that all diabetics need to be conscious of because of the connections between the liver and the pancreas. Which begs the question, how does this apply to diabetes? So again, remember, context is everything. This paper focused specifically on the facts surrounding chronic liver injury. If you have diabetes, you may be saying to yourself, well, I don't have any trouble with my liver. You know, my doctor never told me my liver may be altered. But entertain for the moment that this is expanding on iron's potential to elicit changes outside of just being a simple marker, right? Or ferritin, that should say. This expands on ferritin's potential for being more than just an iron status symbol, right? And like I mentioned before, because of the ties between liver health and diabetes health, this warrants more attention for our liver health, right? If high ferritin is leading to more calcification and fibrosis in our livers, that is not a good thing. Diabetes or no diabetes, right? And we know that the pancreases of those with diabetes carry more iron. We know that the livers of those with diabetes carry more iron. And there is an association between non-alcoholic fatty liver disease and diabetes as well. So this is not cause for concern, but this warrants more interest on behalf of those with diabetes and those researching. All right, and here's just 2 paper titles. This is not an extensive list. If you were to type in liver health and diabetes, you're going to get a lot of different papers talking about different metrics, tying the 2 together. Common presence of non-transferrin bound iron, NTBI, non-transferrin bound iron, among patients with type 2 diabetes. We're going to talk about NTBI in just a little bit. And then elevated iron indices in patients with diabetes. This is all the way back from 2004 and 2006. We have known about this. The research has known about this. It is not being implemented, and here we are, okay? So I recommend you read these papers. There's a lot more that you can branch off of based on the resources and the citations in those papers. And then, this is kind of like extra credit, but non-transferrin bound iron in hematological patients during chemotherapy and conditioning for autologous stem cell transplantation. So iron has an incredibly important role in cancer development as well. This paper was looking at the rates of NTBI, which is a marker of free iron in the cell, bad iron, the inflammatory iron, during chemotherapy. It was very high. It was very high in those experiencing chemotherapy. It was also very high in those preparing for stem cell transplantation. So all of those cancer treatments and immunomodulating treatments, there's some very suspicious, possibly harmful side effects based on those NTBI levels.